So earlier on, we were talking about encapsulation, and now we'll be talking about polymorphism. So polymorphism in object-oriented programming is actually a way of making an object to have different forms. So, for example, an animal can be an object, but animal can be of different types. You know, animal, a dog is an animal, a pig is an animal, a cat is an animal. So, dog also has different features. I mean, the way it sounds, the way it eats. You know, cat also has different features, but at the end of the day, they are all animals. Even cow is an animal. It has different sounds compared to dog. So it's one object animal with different forms: dogs, cat, cow, whatever animal you want to mention. Just like we also have like shapes. You know, a shape can rectangle can a shape rectangle is a shape, square is a shape, triangle is a shape. You know, we have vehicles, we have different kind of vehicles. Um, Benz, you know, Volvo, BMW, different types. So that's actually polymorphism, one object with different forms. And when we're talking about polymorphism, we even have we have two types of polymorphism, which is like the dynamic polymorphism, and we also have the static polymorphism. The static polymorphism can also be seen as the compile time polymorphism, while the dynamic can be seen as the runtime polymorphism. But first of all, I would like us to start with a static polymorphism. So for example, if I have a class, let's assume I have a class like class mathematics. Okay. So in mathematics, I can have something like I can have, let me see, I can have an addition method, okay, public int add, right? Then I can have like num add number one, right? Then in this I kind of return, so this method has been implemented. So I want to have other method with the same method name. So I'm having three methods here now. Okay, now here I'm having three parameters. Okay, plus num3. Okay, so here I can just have one single parameter on the third one, or I can just make this one parameter. So the third one is having one single parameter, right? So I can just do that num1 plus whatever plus 20. So recall here that I have three methods, but in there I have different signatures in it, right? So if I go down here to instantiate the mathematics class, okay, so I will now call the add method m.add, right? So now you can see what happens here. If I click on here, so it's telling me that I should add the value in there, right? So now I'll just have multiple values here. Let's assume I have int okay n1 is equals to 2, int n2 equals to 4, 3 is equals to 6. Okay, so now I can actually put n1 in this method here, n1. So if I put n1 in this method here, it automatically calls the method that has one parameter here. So if I run that, so actually let me print that out. Since it's not a static method, I'll have to use the console.write line to print that out, so we can actually print out the method. So let's see which one of the add method it calls. So we can see it says 22. right? So this is 22. That means the n1 here that is supplied here, let's call this method, so which is 2. 2 plus 20 gives us 22. And I can go ahead and add the other n2 there, and then it will automatically go for the method that has two parameters in there, right? So it will add both numbers together. So we're expecting to add 2 plus 4 together, right? And we have 6, which is correct. And if I put the third one in there, which is n3, so we're expecting to actually add all three numbers together, 2 plus 4 plus 6, which will be 12. So we get that working. So I can even call all three methods. So I can just have like two parameters here and one parameter in the third one. So it will only refer to the method that has the number of the parameters that is being supplied in there. So now that is overloaded method overloading rather. So the methods are overloaded. Same name, different parameters. So same name, different parameters. Same name, different signatures, different parameters. Okay, so that is method overloading, right? So this add method is overloaded. So that's basically static polymorphism. Now, in the case of the dynamic polymorphism, we can have, let me clear up all this one real quick. In the state of dynamic polymorphism, we can actually have a base class, which is like, let me assume that as a subject class. So in a subject class itself, we can actually have something like, we have different kind of subjects, right? We have mathematics, we have physics, or in better aspect, we should just use shape. I think shape will actually be a good idea since we have different type of shape. So we have class shape. In the class shape, of course, it comes with where we know that shape comes with width and length, and we also want to calculate the area of the shape, right? So because like I said in the encapsulation earlier, we also have the protected access modifier type, right? So we'll be inheriting the other shape type will be inheriting from the shape class. So that way I will just go ahead and use the protected access modifier as the access modifier for the shape properties, which include width and the height or length itself. Okay, so let's set that up. Okay, then I can also create a constructor here. So in .NET, in Visual Studio, if you just type the CTOR and tap the tab button twice, so it creates a constructor for you. So now we are going to encapsulate in here. Let's give that an int. Uh, right. Okay, then we'll assign that to it. Right, so that's the constructor for that. So we also want to have a method that will actually calculate the area. So we can have something like virtual int area. So the reason we are using the virtual keyword is to tell the compiler that this method is going to be overridden by by a derived class. Okay, so I'll explain to you how that works as we proceed, right? So one in the we can just print anything here just to keep track of that at runtime. Let's put this is shape class area, right? Okay, just return 0 by default. Right, so now we will need to create another class, which is triangle. And let me just copy and paste that real quick, so we don't have to like waste more time on typing. So of course the triangle class is going to be inheriting from the shape class. We can just name that right. So in the triangle class itself, this will have private properties rather. Let me clear up all of this first for. So we are inheriting from shape class, right? So we also want to inherit the base constructor as well. Okay. Right, then we inherit the base constructor. Okay. So here, what I did here is like we already have a constructor here in the shape class that has already encapsulated the property, right? So I want to have access to this property from a derived class. So that's what I did. I created a constructor of the triangle class, then just inherit the base class. So automatically it gives me access to this property here. That's what the base the constructor inheritance, that's what it is. Then we also create a triangle, an area in triangle class as well. Okay, then let's just put this as a, let's just put a word here just to keep track of that. Triangle class, right? So we want to return, you can see I have access to the width and height here, these properties here. It gives me access to it, right? Because I inherited the base constructor. Okay. So in the triangle class itself, I don't know, I can't remember what exactly is the area of a triangle. So width times height divided by 2, right? I guess so. Anyway, let's just keep that there. The main idea is to give us access to this. So we will also need another class which is more like let's assume the other class will be square class, right? Square is also a shape, and we all know that the area of a square is height times width, right? So I'll just change that here. Square class. I can't remember. Square is actually plus or minus. Plus or multiplication. Anyway, let's just add it together. Times height. Okay, so we have the square class here, right? So now, before I proceed, I want to explain something here. Let's match all the code together. Okay, so here the major area, the main method here is actually the area method. So I have actually used virtual method here. Let me take out the virtual method first of all, so you can actually understand better why we put it there. Okay. All right. So I'll go ahead now and instantiate the class shape s equal to new shape. Okay. Uh, so the other class is shape triangle, right? Shape t equal to new triangle. Then the other one is square, shape square equal to new square. So let's try and print out dot area, shape dot area, then triangle dot area. Let's print that out, see what we have. Okay, let's go see what we have, see what method it calls, right? So now it's only calling the method in the shape class, right? This is shape class, this is shape class, this is shape class area. But why is it only calling this method here? So it's only accessing this method even though we instantiated all three classes, right? So that is because it is only reading this method, this area method. We are calling only that area method here. So it's not even recognizing all this area method. All this area method has been hidden. So now we need to tell the compiler that, okay, I want you to access all the other methods in the other class. So that way, this is a virtual method. Okay, you are reading this method itself. Sorry, that's spelling error. You read this method, then it will be overridden by other class. So the moment it gets here, it should be overridden, override. So this is overriding this method here. So it will override it, but the moment it hits the triangle class, it override this one, and then it recognizes this one. Same thing here, we have to use the override keyword here too. So what if we run this now? Are we going to have access to the methods in there? Let's see that. Okay. So let's run that and see what we have. So you can see we have access to it. This is shape class, this is triangle class area, this is square class area, right? We have access to that. Fine. So that is the duty of the virtual and overriding method. So, and then um, implementing the shapes in there actually, because we actually have arguments in the constructor here, but we haven't used it, right? So what we are going to do is we are going to create a service class, a middleman class, more like an abstract class, not really an abstract class, but just like a caller class. Let's just call that class middleman, right? So we also want to have something like a method there, public void service. Let's just give the service. Now I'm going to inject the shape class there itself. So this process here is actually dependency injection on the method level, but we'll get to dependency injection explanation as we proceed. But please be aware there is something called dependency injection. I'm injecting the shape in this method here so that this class can depend on the shape class to actually execute what I'm trying to implement inside of here. So that's something like int j here. Okay, then the j will be calling the integer method in those classes here, right? So I can just do I'll just do the shape sh dot area. Okay. So now going forward here, what I'll be calling here, I'll be calling this class, this middleman class here. I'll be instantiating this middleman class here, right? So I'll be instantiating this middleman class here, middleman m equal to new middleman, right? Okay. Then I'll just get rid of all this because I've already used this dependency injection to get access to all these areas here. So the moment I'm calling this service method, it's coming with a requirement to inject the shape class that I want to implement here. So what I'll do is clear all this, then use the middleman object to call the uh, service method, and the service method will require me to inject a shape class there. So I already have the shape class here, right? Okay, so I can just put that there. We'll do for let's just do for triangle and square. Let me call for square as well. Okay, so we got all those two set up. Then let's see what we have here. Let's run it and see what we have here. It's probably going to give 0. Fine. So the reason we are getting 0 is because we have not actually assigned value to the classes of the triangle and the square classes. So we need to remember we have two parameters here, but we didn't assign value to it. And by default, C# class has a default constructor. So this is calling default constructors. So in here, what I can do is I can just assign maybe like 5 and 9 there. And here also I can assign like maybe 4 and 2 there. So it will use this input to calculate the area. So the area for triangle and square will be displayed here. So triangle class area is 22, square class area is 8. So this is dynamic polymorphism that we've implemented here. So yeah, I mean you can play with it, and if there's any question you can put it in the comment section. And then in the next video we'll be talking about generics in C#. Thank you, and I'll see you in the next class.